Hello everyone, welcome back to the YouTube channel of Developers and Coders Club. Today we are here to discuss the problem Serval and Toxel array, which came in recent contest of Codeforces, that is round at 153. So let's see what is problem asked to us, then we will see how to proceed. So basically in the problem there is given an array which is have unpairwise distinct elements. That means there will not be any element which occurs more than one times in this array. Then, in order to get more arrays, Toxel performed M operation with the initial array. So, he is going to perform M operation on this initial array. And in the ith option, what he will do? He modified the pith element of the I minus 1 array to vi. That means we will given a pi and a vi. And what we will do in ith operation? We will check pith element of this initial array, not initial array. I mean to say that we will check pith element in our current array, and then we will update that with vi. Like if pi is pointing to 2, then what we will do? We will change our second element to vi. Okay. So resulting in the ith array, the initial array is numbered as 0. So in we will make changes in I minus 1 array, and our initial array is numbered as 0. During modifications, Toxus guaranteed that the elements of each array are still pairwise distinct after each operation. That means if we are performing this type of operation, still after this, the elements in that array will be pairwise distinct. There will not be any element which occurs more than one times. And finally, Toxel code M plus one arrays and denoted them as A0 will be A1, A2 till AM. And for each pair I and j, and I j is lying between 0 to 1, Toxel defines its value as the number of distinct elements of the concatenation of ai and aj. And now Toxel wonder what is the sum of values of all pairs. So we want to find the sum of all pairs. So first of all, understand it with the test cases. That here this is size of array is 3, that is 1, 2 and 3, and total operations are 2. That is first of all first operation is 1 4, and then second operation is 2 5. So what we will do in first operation? We will select first element and change that with 4. So that will be 4, 2 and 3. Then in second operation we will select second element and change that with 5. So that will be 4, 5 and 3. So let's mark it A, this is B and this is C. So what will be the pairs? That can be AB, that can be BC and that can be AC. So what is given in our question? That we will select two pairs AI and AJ, concatenate with that and find that how many distinct elements are present in that concatenated array, and we will find the total sum of all these pairs. So if we concatenate A and B, then that will be 1, 2, 3, 4, 2, 3. How many distinct elements are here? That is 4. Then if I concatenate B and C, that will be 4, 2, 3, 4, 5 and 3. How many distinct elements? That is 4, 2, 3 and 5. That is also 4. Then for A and C, 1, 2, 3 and 4, 5, 3. So here are 5 elements. So total sum 4 plus 4 plus 5, that is 13. So that is answer for this test cases. So now let's understand it with basic condition that first of all let's make an example that there is a three size array, that is 1, 2, 3, and we will perform 4 operations here. So first of all we will do like change first element to 4, that will be 4, 2, 3. Then second option can be change third element to 5, that will be 4, 2, 5. Then change second element to 1, that will be 4, 1, 5. And the last operation can be change first element to 3, so that will be 3, 1, 5. So there is a condition that we need to make operations such that there should not be any same element in the particular array. So these are the operation and these are the array that will be formed. So First of all, let's check what is the answer for this. So if we select 1, 2, 3 and 4, 2, 3, 1, 2, 3 and 4, 2, 3, then how many distinct elements are there? That is 4. So 4 plus then 1, 2, 3 and 4, 2, 5. This and this. So 1, 2, 3, 4, 2, 5. 5 elements are distinct here. Then 1, 2, 3 and 4, 5 and 5. Again 5 elements distinct. Then 1, 2, 3, 3, 1, 5. 4 elements. Yeah. Then we have done with this. Come on this 4, 2, 3 and 4, 2, 5. 3 elements. Then 4, 2, 3, 4, 1, 5. 4, 2, 3, 4, 1, 5. How many distinct? That is 1, 2, 3, 4, 5. 2, 3, 5, 4. Okay, 4, 2, 3, 4, 2, 5. There are 1, 2, 3, 4. Okay, that is 4. Then for this 4, 2, 3 and 4, 1, 5, 5 elements are there. 4, 2, 3, 3, 1, 5. So 1, 2, 3, 4, 5 again 5. Then for 4, 2, 5, 4, 1, 5. That is 1, 2, 3 is not there, so 4 elements. Then 4, 2, 5, 3, 1, 5 again 5. And 4, 1, 5, 3, 1, 5. That is 4 elements. So that is answer for this. That is 9 plus 9, 18 and 22, 32, 37 and 45. Okay, so now let's check that here is one research planet. So can we make an understanding in which we try to find out that this one how many pairs are there in which there will not be anyone. How many pairs are there? There will not be anyone in which one will not make any contribution. So we can see that here is one is written. So we can see if we select only these two pairs, only these two arrays, and we make pair of these, then only there will be condition in which one will not be contribute. Okay, so I can check that one will contribute. Well, one will not be contribute in 4 to 3 and 4 to 5. So how many pairs will be found from these two arrays? Only one pair. Only one pair. There will be only one pair in which one will not contribute. Okay. Then check for 2. 2, 2, 2, and there are also again two arrays in which 2 is not going to contribute. So how many pairs can be found from two arrays? That is one pair. Then for 3, okay, so I think I have made all two. Like every element is coming 3 times only. So that is not making any changes in. Okay. Again 3 also making one pair. Again 4 also making one pair. And again 5 also making one pair. Why? Because 3 coming in 3 arrays. 2 arrays are there in which 3 is not coming. If we make pairs from these 2 arrays, in that 3 will not contribute. Again for 4, this array and this array. And again for 5, this array and this array. These are 2 arrays in which 5 will not contribute. So that is not making any other condition. So for that, let me take another example. I will not make so much big. Uh, just take 1, 2, 3, then 1, 2, 4, then I'm changing it. Okay, then 2, 3, 4, okay, 3 to 4, then can be 5 to 4, and it 1, again 1, 2, 4. In this, there is two arrays in which one is not going to contribute, so we'll make one pair from these two arrays. For 2, there is not any array in which 2 will not contribute. So from 2 we cannot make any pair in which 2 will not contribute. Okay, there is 0 pairs in which 2 will not contribute. For 3, mm, there is 3. So we are getting 3 arrays in which 3 is not occurring. That means if we make pairs from these 3, then in those pairs 3 will not contribute. So from 3 arrays, how many pairs we can make? Like A, B, C. So 1, 2 and 3. We can make 3 pairs in which 3 will not contribute. Okay, so for 4 there is only one array in which 4 is not going to contribute. So from only one array we cannot make any pair, so again 0 pairs. And then for 5 1 there is only one array, so remaining 4 arrays are there in which 5 is not going to contribute. So from 5 arrays, from 4 arrays, how many pairs we can make? That is 4 into 3 by 2. Am I right? Like A, B, C, D. So one can be a B, one can be a C, one can be a D. Then B, C, B, D, then C, D. So 1, 2, 3, 4, 5, 6. Yeah, that's correct. So there will be 6 pairs in which 5 will not contribute. So that is formula for this, n into 1 minus 1 by 2. So what we can do, if anyhow we get total frequency, of 1, 2, 3 and 5 whole numbers, then what you can do, like here frequency of I is 1. Okay, so we know that total how many these array will be formed. This is zeroth array, this is first, this is second, till then m operation. So array m arrays will be formed. Then if we find that frequency of every element, like 5 is occurring one time, so we will subtract 1 from this. What I want to say that m minus frequency of any element, this will give total arrays in which this particular element is not coming. Then let's call it lambda. Then how many pairs will be there? That is lambda into lambda minus 1 by 2. This is the count of pairs in which that particular element will not contribute. So what we will do? So there is one doubt that how we will calculate the frequency of every element. I will discuss that later. First of all, just think that anyhow we have calculated the frequency of every element. Then what I will do? I will subtract that from m. From that I will get total arrays in which that particular element is not coming. That is lambda. Then we will check that how many pairs we can make from these lambda arrays. So that is lambda into lambda minus 1 by 2. So we all know that total, if we have m plus 1 arrays, then how many pairs we can make? That is m plus 1 into m plus 1 minus 1 by 2, that is m by 2. This is total arrays we can make from m arrays. We will subtract it from this lambda into lambda minus 1 by 2. This will give for a particular element, this will give that how many pairs are there in which this particular element is going to contribute. Okay, because this is count of total pairs and this is count of those pairs in which this particular element is not going to contribute. So this whole part is going to give us that how many pairs there will be in which this element is going to contribute. So what we will do, we will check for 1 to n plus m, because that is given here, that element will lie from n plus m to till n plus m. So we will check from 1 to n plus m for every element. We will find this and subtract that from this and store that all in m, and in last we will print as. Now there is doubt that how we are going to find the frequency of every element. How we are going to find the frequency of every element. For that, what I can do? We all know that there will be given an initial array that can be like. So let me take a same example. What is that? 1 2 3 1 2 4. 1 2 3 1 2 4. Then 3 2 4 5 2 4. And last one is 1 2 4. So that is our initial array. Here we performed operation, that is convert third element to 4. Then here we performed convert first element to 3. Here we performed convert first element to 5, and here we performed convert first element to 1. Okay, so what I can do for counting the frequency? So, so just think that uh, these are okay. These are the operation which we are going to perform. These are total M operations. And just think that here we are changing our first element, here we are changing our first element, and again here we are changing our first element. Okay. I want to find the frequency. First of all, there will be an particular element on the first index. What will be the frequency of this element? What can be that? For that, I will check that in our operation list where next one is coming. So that is coming here. So what I will do? I will check index of this in our operation list and subtract that from this. That will give me frequency of this element. Okay. Then again, just think that on first index that call that 4, write 4 on our first element, and here they tell that write 6 on our first element. What will be the frequency of 4 here? That will be subtract next one index in operation list in our operation list from this. That will give us 2. So that will be the frequency of 4. Why? Because first of all 4 is coming here, then again 4 is coming here. There will be some other operation like change to this one, something like that. But 4 is coming on first index 2 times. And this is for first. Check, same check for second, same check for third, till or nth index. So what we can do? We can make a vector of array like vector of 1, vector of 2, vector of 3, vector of 4 until n. What it will store? It will store that how many times, like what is the index on which we are changing our first element. It will store on which index we are changing our second element, and this is storing on which element we are changing our third element. Okay, so if we take example of this, then just think that okay, let's take it, but the same operation, so that will not make any significance. So just to think that we are performing 7 operations. So first operation is change second element to 3, then our initial array is 1, 2, 4. This is our initial array. First operation is change second element to 3, then change third element to 5. This will make 1, 3, 4. This will make 1, 3, 5. Then again there is change first element to 4, then change fourth element, that's not fourth, sorry, change third element to 2, then change second element to 1, then change third element to first element to 5, 3, 3 next operation, that is change, let's take again first and change that with 3. So we can see that first of all 1 is coming on our first element, first index. Then again we are changing our first index here. So there will be 2 operations in which first 1 will be on our first index. So how many will be there total? Let's take it 0. This is first operation, this is second, this is third operation. So what I'm going to do, that I will check where our next one is coming. That is coming in our third operation. We will subtract third minus 0. That will give how many arrays are there in which first is on our first index. Okay, 1 is our first index, so that will give us 3. Then if I again check our next first, that is here, so we can see that we are changing 1 to 4. So from here to here, there will be total 3 arrays in which 4 will come on our first index. So we can subtract, this is 3, this is 4, this is 5, this is 6. So if we subtract 3 from 6, that will give a frequency of 4, that will be 3. There can be another frequencies also, but till now I am checking only for first index. If we check for second, third, fourth, that will give us that frequency of another force also. Okay, this is frequency for only these 3 ports. That will be in another condition. Okay, so what I will gonna do, that in vector 1 I will make a pair of vector. This is holding pair, and what is this, that index of where 1 is coming, and comma the element on which what is written here, like 1 is there, that is 4. So let's take call it that vi. This is containing that, and next index and next vi till then that. So that will count our total frequency of element. Okay. So our code will make it more understandable. That's it. First of all, I'm making a VII BTR n plus 2, that is simply a pair of vector. Then for first of all, I'm marking it 0. That is like on our zeroth operation, this array of I is coming. On our zeroth operation, this array of I is coming in VTR1, VTR2, VTR3 all. Okay. Then in our all M operation, I'm adding in VTRX, that is our index on which we are going to change. And what I am going to add, that is on which index in our operation list this is coming. And last one is what is that element. Then what is this, that in last, if all operations are done, then in last also I am marking that that is complete of list, and just marking that all elements make that -1. That's only making the frequency of all last elements. Like here, after this 3, no 3 is coming here. Okay, so but on third index 2, 2, 2, 2 is written here. So what I will do, I will make a m plus 1 vector, and that will say that here last all operations are going to be done. So there will be an 3 here, and we will subtract this index from this. So simply that is calculating our last frequencies. That is for last condition, and that is for our initial condition. And this is total operation which we are going to do in middle. Then in final of what I am gonna do, that I will update our VTR I plus 1 j minus 1 dot second. This is these elements. These elements. Okay. I'm increasing its frequency with the current j minus previous j. That is giving us frequency of that, and that is frequency. Then what I will do in final, that there will be total m plus 1 arrays, decrease our frequency from that. This will give us that how many arrays are there in which this element is not coming. What is that element? That is I plus 1. And then I'm adding what is gg, that is m into m plus 1 by 2 total pairs, and subtracting that with uh, how many pairs we can form in which this element is not coming, and add those all values, and we will get that. So that is a complex explanation of this problem. So I hope you all understand it. So see you in the next problem. Till then, happy coding. Bye bye.